So no energy stored in the inductor or the capacitor. So when the switch in the circuit show in this figure is closed at T0, find the capacitor voltage. All right, again, I always need to find which case is this. So to do that, we need to find alpha, because this in series, so alpha is in a different form. So R here is 280 divided by 2L. L is 0.1. Then we can find alpha. Pretty easy, and we can find over 0. Square is a bit easier, so we don't need to dealing with this square. So 1 over LC. Okay, and then we can have this one equals to 1 over L, 0.1. C is 0.4, 10 to the negative 6. Okay, then we will figure out this one is actually larger than alpha square. So because this one is larger than alpha square is underdamped, so we will pick here. Okay, and then you can see we're gonna change this equation to the capacitor voltage. Then we copy down almost everything, e to the order of alpha t cosine omega dt plus b2 e to the order of negative alpha t sine omega dt. And we also need to including, sorry, it's not I here, so it's VC infinite. Okay, we're including the infinite value here. And then we gonna find the parameters. We know alpha already. There's something we haven't know yet is omega d is omega 0 square minus alpha square and square root. Okay, and you plug in numbers in, that is a 4800, and now B1 and B2. Okay, then we're going to use these. So first we have the C initial value, the capacitor voltage. So if you look at that one, there's no energy, so we know that's equal to 0, and that's equal to B1 plus VC infinite. Okay, what is the infinite voltage here? So when this one reached to a steady state, so when this one reached to a steady state, we have this thing is be closed. Okay, and the inductor become a conductor, just one line, and resistor we have that. Okay, we're going to keep charging until the end. So this one gonna equals to the input voltage, right? So that's 48 volts. Then we know that B1 is negative 48. Okay. What about the next part? The next one is we're using the dV/dt. Okay, we use dV/dt. So dV/dt, so this is Vc, so it's gonna relate it to something about the capacitor current. Okay, is related to capacitor current, and I think it's a C dV/dt, so it's over C like that. Okay, and the capacitor current, we probably don't know capacitor current, but it's always related, is equals to inductor current because they are in series, and we know this one's 0 because there's no energy in inductor, so we know the whole thing is 0. And because this is 0, and then that's a negative alpha B1 plus omega d B2 equals to 0. And then we know alpha, we know omega d, we know B1 as well. So in the end, we can derive that B2 equals to negative 14 as well. All right, then we just plug in everything into it. So we got a B1, which is, how much is that? We got a B1 is negative 48. We can put this e to the order of negative alpha t to the end. Then we got this one, cosine, and inside that one is omega d for A00 t minus, because this another B2 is a minus as well. So sine for A00 t, okay, and put it into brackets, multiply e to the negative alpha t, okay, and plus the infinite voltage, which is 48. That's it.